Alright guys, make sure that you're taking your notes. So this is station 1. Make sure that you're using your notes here. So when we look at chemical reactions, so the chemicals don't break apart or come together or rearrange just randomly. They do it for a reason, and we'll talk about that later. But there is some pattern that we observe. So we call them types of reactions. There are tons of different types of reactions. I'm just giving you an example of the simplest ones. Okay, so we're going to be looking at 5 types of reactions, which is synthesis, decomposition, single replacement, double replacement, and combustion. Okay, so synthesis, sometimes people call it a combination. It has a general equation of one chemical comes together and reacts with another chemical, and they kind of bond together. We call them synthesis. So it's two things coming together. Okay, an example of this is sulfur that reacts with oxygen to form sulfur dioxide. So you can see those two things came together to form one single thing. In nature, we have tons of examples of synthesis. You can think of when things grow, for example, when your fingernails grow, or when plants grow, right? Or when your hair grows. Those are all examples of synthesis. So synthesis is things coming together. Okay? Decomposition is absolutely the opposite thing. You have one thing, and that thing for some reason, could be heat or it could be some sort of catalyst, it breaks them apart. So one thing creates two separate things. Okay, so we call them decomposition. An example of this is when calcium carbonate is actually heated. When calcium carbonate is heated, it forms calcium oxide plus carbon dioxide. Okay, so those two things came from this. Again, there's tons of examples of decomposition. If you leave your food out for a long time, it begins to decompose. Same thing with leaves. So decomposition is the opposite of synthesis. Okay, so a new category is called replacement reactions, and it pretty much, as the name says, is when one thing replaces something else. So the general equation here is A plus BC yields B plus AC. So as you can see here, A replaces B. Okay. Could A have replaced C? Sure, it could. It still would be a replacement reaction. Okay, so A replaces B. An example of this is zinc reacts with hydrochloric acid to form hydrogen gas and zinc chloride. So notice here that zinc replaced hydrogen. Right? So hopefully you can see that. And you can pause the video to make sure that you see that zinc replaced hydrogen. And since that's only one thing being replaced, right, in this case B, or in this case hydrogen, we call it single replacement. As you may guess, there is such a thing as a double replacement, and as the name says, it's two things being replaced. So you can think of them as switching places. So in this case, this is the general equation. This is not a element. Those are not elements. It's just in general. So you have AB plus CD equals AD plus CB. As you can see here, the A and C switch places. Okay, so A and C switch places. Usually A and C are metals. Okay, so here's an example. Hydrochloric acid reacts with sodium hydroxide to form sodium chloride and water. Okay, the H and the Na replaced each other, switch places. Okay, hydrogen is not a metal, but in here we consider it to be a metal. Okay, so the H and the Na, or the hydrogen and the sodium, they switch places. And then the last one, it is combustion. We studied combustion quite a bit. We had a whole unit dedicated to it. But again, it's a type of reaction, so we are going to briefly talk about it. So a hydrocarbon, so the general equation for combustion, there is no A, B, or anything like that, because it's very fixed. Usually a hydrocarbon is anything made out of hydrogen and carbon, reacts with oxygen to yield carbon dioxide and water. So carbon dioxide and water will always be the product. Now, this is theoretical. There's all sorts of different ways that combustion take place. So this is just a theoretical, just a simplified version of it. Okay, I just wanted to keep that in mind. An example, that's propane. Okay, so a lot of you use propane for cooking. Okay, so that's the gas in your stove. Or maybe if you go camping, that's the little small container of gas that we use in a barbecue. So propane reacts with oxygen in the air to yield carbon dioxide and water. Okay, so the smoke that you would see would be the water. Alright, so those are the different types of reaction. Let me know if you have any questions.